In this video, we're going to multiply algebraic expressions to write them in an equivalent form. And we'll start with a simple example where we're distributing. We have -3 times the quantity 2x minus 1. So what we do is we multiply the -3 onto both terms. So our answer would be, if I did that, I would have -3 times 2x, that's minus 6x. And -3 times -1 is +3, so plus 3. So these are equivalent. -3 times the quantity 2x minus 1 is equivalent to -6x plus 3. We can do the similar thinking with number 2, where we're multiplying these two quantities. In between here, there's an implied multiplication. So we could distribute both terms onto both terms. I like to arrange this as a rectangle. We call it an area model. So I'm going to write 3x minus 3, make that a little better, and 2x minus 1. Those are my two pieces that I'm multiplying. And now I can multiply them in pieces that I arranged by these four quadrants. So 3x times 2x is 6x squared. This quadrant right here would be 2x times -3, which is minus 6x. 3x times -1 is minus 3x. And -3 times -1 is positive 3. So now that I can see what all of these products were, the answer is going to be a sum. Just like this up here was -6x plus 3, I'm going to add up all four of these to get my equivalent expression. So I have 6x squared. Then I have minus 6x minus 3x, so combined that's minus 9x. And I have a positive 3, so plus 3. The reason this is called an area model is because this is a rectangle, and the area of a rectangle is the base times the height. So multiplying these two is like an area. It's like base times height. Or if you think of this like a house with 4 rooms, the area is also the area of each room added up. So if we add up all 4 of these terms, it should be equivalent to base times height. So that's why we call it an area model. All right, we're going to apply the similar thinking here. Just one more that's similar to try. We have 3x minus 1 and 4x minus 2. Make that look a little more clear. Okay, 3x times 4x is 12x squared. 4x times minus 1 is minus 4x. 3x times minus 2 is minus 6x. And -2 times -1 is positive 2. If I add up all 4 of the rooms, I have 12x squared. Minus 6x and minus 4x combined is minus 10x. And I have plus 2. Last one here. It looks more complicated because now I have more terms, but we just set it up in the same way. So I have 2x minus 3. I'm going to put that on the side. 2x minus 3. And then because I have 3 terms, I made 3 columns. So I'm going to have 3x squared minus 2x minus 1. Okay, now I multiply them. 2x times 3x squared is 6x cubed, because x times x squared is x cubed, and 2 times 3 is 6. 2x times -2x is -4x squared. 2x times -1 is minus 2x. And do the same thing on the bottom row here. 3x squared times -3 is -9x squared. -3 times -2x is positive 6x. And again, -3 times -1 is positive 3. Collecting all my terms, I like to look at the highest exponent, the highest power. So I have a cubed, 6x cubed. Then I have squared terms. I have a -9 and a -9 and a -4. So combined, that's minus 13 x squared. Then I look at my x terms. I have a 6 and a minus 2. So combined, that's 4, and it's positive, so plus 4x. And then I have my 3, and it's positive, so plus 3. Make that look a little better. So this 6x cubed minus 13x squared plus 4x plus 3, it's equivalent to this product up here, the product of these two terms. So that is multiplying algebraic expressions to write them in an equivalent form.